Okay, let's continue from the last video. Okay, so let's clear this and pay day. Okay, and pay day. Okay, so when you use clear command to remove more than one variable, separate variables by a space. Okay, not by a comma. Okay, so I give the first name and the second name. Also it shows how you should give this command here. Okay, so you can see payday variables are gone. Okay, now I can clear all the variables here. I just do clear, I will just say clear. Okay, it will clear all the variables from the workspace. So that's about the clear command. Okay, vector is a special type of a matrix having only one row or one column. Okay, vectors are also called list or arrays in other programming languages. Okay, so a vector is a matrix with one row or a column. Okay, so if it's with rows, we call it a row vector. So a row vector will contain only one row, a column vector will contain only one column. Okay, you can simply create a vector by listing the values. Okay, so if I do this, I can create a vector containing 1, 2, 3 and 4. I left the semicolon so you can see. Okay, so this is a row vector. Also you can create a row vector by using 1, 2, 3, 4. Okay, so that will create a row vector also. Okay, if I want to create a column vector, I have to separate items by semicolons. Okay, I have to separate items by semicolons. Okay, let's say this B 1 semicolon 2 semicolon 3 semicolon 4. Okay, so if you here look at the sizes here, size of A, you can see 1 by 4, no, that is 1 row and 4 columns. Okay, sorry, yeah, 1 row 4 columns. And if you look at size B, it's B is 4 by 1. Okay, actually MATLAB considers everything as a matrix, that's why it's called MATLAB. Okay, so in MATLAB everything is a matrix. Okay, so this column vector, it consider a row vector is considered as a 1 by 4 matrix, column vector it considered as a 4 by 1 matrix. Okay, important to remember, you have to use this semicolon, so square bracket when you are creating a vector. Okay, square bracket. Okay, so if you think of a scalar, just a real number, okay, MATLAB will consider it as a 1 by 1 matrix. That's why we getting here 1 by 1. Okay, and we can create a empty matrix, empty vector by just giving this. Okay, we can store values later. Okay, you will see why we want to create empty vectors later. Okay, but if you want, you can create by just giving this. Okay, I'll clear the screen again. So Also, if I have two vectors, 1, let's say 2, 3, and C, 4, 5, 6, I can create another vector, let's say A, by combining these vectors by just placing them like here, B and C. Can you guess how the resulting vector will look like? Okay, it will look like just combine them together. Okay. Okay, also we can do D equals 1, 2, and let's say minus B. Okay, like that we can combine it with operation. Can you think how will this look? Okay, see 1, 2 and B, every element multiplied by a negative sign. Okay. Also, if you use this colon operator, you can create a unit paired vector x with element x, okay, with elements, okay, elements j to k. Okay, sorry, I forgot. Yes, I forgot to j to k. Okay, so this is useful. For example, let's say I want to create a vector containing 1 to 100. I can simply say x equals 1 colon 100. Okay, it will create a vector 1 to 100. Or if I want 10 to 20, I can say x equals 10 to 20. Okay, so it will be at a vector from 10 to 20. And sorry, okay, if I use colon ijk, it creates a regularly spaced vector x from j to k. Okay, so with I element, using I as the increment. Okay, sorry, I as the increment. So if I do this, it's create a regularly spaced vector x from j to k using I as the increment, okay, between elements. Okay, so for example, if I go, let's say y equals 2 0.1, I'm checking what is the increment. Okay, so I is the increment, 0.1 and 5, it will create a vector from 2 to 5, okay, containing, and if you look at the increment, it's increased by 0.1, 0.2, 0.3, likewise. Okay, so each time it increases by a 0.1, which is the value I showed here. So if I want to create a vector listing the even numbers 2 and 100, so even numbers can between 2 and 100, I will start between 1 and 100. Sorry, I will start from 2, because that list I know start from 2 and end at 100, and to get even numbers I increment by 2, no? So this list all the numbers 2 to 100, even numbers. Here I started from 2 because I know after 1 first even number is 2, and ended from 100 because I know 100 is a even number. Okay. Let's go over the linspace command. Okay. So the linspace x1 x2 returns a row vector of 100 evenly paired points between x1 and x2. Okay, it will start from x1 and go up to x2 and create 100 points in between them. Okay, so example we can go t equals in case I can select this first command. Okay, see if I do 1 to say 100, it will create 100 equally paired point between 1 and 100. Okay, and if I go 1 to 10, again it will create 100 points between 1 and 10. Okay, these points are equally spaced or evenly spaced. And if we give another parameter here, it will create this many points. Okay, if I omit this, it will create 100 points, but if I give this parameter, it will create 10 points. See, now it created 10 points between 100 and 10. Okay, so if I give a value here if I give the value, it will create that many points. If I omit that, it will create 100 equally spaced points, otherwise this many equally spaced points. Okay, this is useful when we want to create equally spaced vectors. We can use that. You will see why we need this later. Okay, go y. Okay, I mistakenly put 100. Okay, I mean to put log 1 to 2. Okay, now this will create 50 point logarithmically phased points. Okay, so it is creating points between, if I give input A and B, it creates 50 points between 10 to the power A and 10 to the power B. Okay, so here I gave what, 1 and 2. Okay, so 10 to the power 1 is 10, so it will start from 10, and 10 to the power 2 is 100. It will go up to 100, and in between it will create 50 points, but logarithmically spaced. Okay, 50 points logarithmically spaced. Okay, include these two, so it has 50 columns. Okay, so there are 50 columns including this 10 and 100, Okay, there are 50 points. Okay, so here if you look at the distance, you cannot see that they are equally spaced, okay, because they are logarithmically spaced. For that we can take the log of this vector. Okay, if I take log 10 of this vector y, now you can say this is equally spaced. See, okay, so in the log space these points are equally spaced, the log base 10, okay, base 10 log space, they are equally spaced. Okay, that's why you we are calling them logarithmically spaced. Okay, but in base 10. Okay, remember that. Okay, and same way I give eleven points. Okay, it will create 11 points logarithmically spaced between 1 and 100 again, because this is 10 to the 1 and 10 to the 2, 11 points. Okay, again we cannot see how they are spaced, we have to go to the log base 10 of y. Okay, I take again log base 10 of y. Now you can see they are equally spaced. Now the distance between each point is 0.1, that is but in log space. Okay,